The basic proportionality theorem, also known as Thales' theorem, is a fundamental concept in geometry that describes the relationship when a line is drawn parallel to one side of a triangle. The theorem states that if a line is drawn inside a triangle parallel to one of its sides and it intersects the other two sides at distinct points, the line divides those two sides into segments that are in the same proportion. Understanding the proof of the BPT. We can prove this theorem by considering a triangle and its areas. Setting up the triangle. Imagine a triangle called ABC. Now, picture a line segment, D, drawn across the triangle. Point D is on side AB, and point E is on side AC. The line D is drawn specifically so that it is parallel to the base of the triangle BC. Our goal is to demonstrate that the length of AD divided by the length of DB is equal to the length of A divided by the length of EC. The construction steps. To prove this, we need to add a few lines to the triangle. First, we connect point B to E and point C to D. Next, we draw a perpendicular line from E to side AB and another perpendicular line from D to side AC. These perpendicular lines represent the heights of various triangles we will examine. Comparing triangle areas. We know that the area of any triangle is calculated using its base and height. We compare the areas of different triangles formed within the larger triangle. First, we look at the triangle ADE and the triangle BDE, both sharing the height represented by the perpendicular line from E to AB. When we compare the area of triangle ADE to the area of triangle BDE, the ratio of their areas is equal to the ratio of their bases, AD to DB. Next, we look at the triangle ADE again, and this time, the triangle DEC. These two triangles share the height represented by the perpendicular line from D to AC. Similarly, the ratio of the area of triangle AD to the area of triangle DEC is equal to the ratio of their bases, A to EC. The key insight. Now we consider the triangles BDE and DEC. These two triangles are positioned on the same base, which is the line segment D, and they are located between the same parallel lines, D and BC. Because they share the same base and are between the same parallel lines, these two triangles have the exact same area. The conclusion. Since triangle BDE and triangle DEC have equal areas, the ratios we established earlier must also be equal. This proves that the ratio of AD to DB is exactly the same as the ratio of AE to EC. Therefore, the line parallel to the base divides the other two sides proportionally.